In this video today, I'm going to go over the volume of pyramids and cones. So our objectives are to learn and apply the formulas for a volume of a pyramid and the volume of a cone. The first one we're going to talk about is a cone, and I kind of want to point out something to you first. That a cone is 1/3 of a cylinder, and that's because both of them have a circle base, and if it was a cylinder, it would have a circle base on the top and the bottom. If that was the case, then the volume would just be base times height, where the base is circle, and then we're multiplying by the height. If we were to take the measurement of what fills a cone that is the same height as and the same radius as a cylinder, the cone would be 1/3 the volume of that corresponding cylinder. So that's why it's 1/3 base times height. It says here, find the volume of a cone with a radius of 7 and a height of 15. Give your answer in both terms of pi and round it to the nearest tenth. So obviously the two measures we need to pull here are that the radius are 7 and the height is 15. And this one's pretty easy because we're literally just plugging it into the formula. Volume equals 1/3 pi r squared times h. Now when I do this, I don't do the 1/3, I divide. So when I typically do this, I do 7 times 15. I divide that by 3, and then I add pi at the end. So so basically by doing that, I get 245 pi centimeters cubed. Remember it's cubed because we're talking about volume. And then if I were to multiply the 245 by pi, I'd get 769.7 centimeters cubed. Our next one says, find the volume of a cone with a base circumference of 25 pi inches and a height 2 inches more than twice the radius. So this one we need to talk through because we need to figure out what the height is. And it says circumference here, and that formula is on your formula sheet, so we're going to use that first. That formula is 2 pi r, and that equals 25 pi. So we're going to divide both sides by pi. When we do that, we're going to get rid of the pi here and here, and then we're also going to divide both sides by 2, and half of 25 is 12.5. So that's our radius. Now to figure out our height, it says the height is 2 inches more than twice the radius. So more obviously means we're going to add the 2. So we're going to do plus 2 for this, and then it says more than twice the radius. So that means we're going to multiply 2 times the radius. So to find the height, we're going to do 2 times 12.5, and we're going to add 2 to that. So that's 27 inches. And so then we're just going to plug those values into our formula, volume 1/3 pi r squared h. So here again, I would typically just do 12.5 squared times 27, divide that by 3, and then add the pi at the end. So that would be 1,406.25 inches, pi inches cubed, and then if I multiply by pi, I get 4,417.9 inches cubed. This one says find the volume of the cone. Now the problem with this one is we have the slant height. This 34 over here is what we call slant height. We don't have the actual height, so we need to use, guess what, Pythagorean's theorem to solve for the height of this cone. So when we do that, we're going to do 16 squared plus h squared equals 34 squared. When we do that, we get that the height squared is equal to 900. We're going to take the square root of both sides, and that's going to give us 30 for the height. So now we have that the height is 30. So now we have the radius and the height, so we can find the volume of this cone. So to do that, we're going to again do our 1/3 pi r squared h. And as I've said before, when I'm doing this, I'm going to actually do it like this. So we're going to do 16 squared times our 30, divide that by 3, and have our pi at the end. That's the way I do it in the calculator. And when we do that, we get 2,560 pi centimeters cubed, and then when we multiply that number by pi, we get 8,042.5 centimeters cubed. So this one says find the volume of the cone. The difference with this one is that, actually, I'm not going to say that. You guys go ahead and do this, pause the video, and then once you guys have completed it, you can come back to me and I'll go over it. Okay, so the very first thing I notice is that I don't have the radius of this cone, I have the diameter. So to get the radius, I have to divide the diameter by 2, so our radius is going to equal 9. Then I can do the rest of the problem because now I have the radius and the height. So again, remember, I would do it this way. 9 squared times 8 divided by 3 with pi at the end. Because I can do this in my calculator just like that. So our volume is 216 pi meters cubed, and when we multiply that 216 by pi, we get 678.6 meters cubed. So the last one says, or the next, check it out. Again, you can pause it here and come back to me when you're done. So this one says find the volume of a cone with a base of 36 pi feet and a height equal to twice the radius. So here again, what I'm going to do is go ahead and work through this to figure out what the radius is. So it says that the base is 36 pi. We would be able to cancel out these pi's, and then we would take the square root of both sides here. So we know that r is 6. So our height, it says, is equal to twice the radius. So that means we're going to do 2 times the radius to get the height. So here again, if I were doing this problem, I would do 6 squared times 12 divided by 3 times pi in my calculator. But remember, we want the answer with pi first anyway. So that's 144 pi feet cubed, and then when we multiply 144 by pi, we get 452.4 feet cubed. This next one says exploring the effects of changing dimensions. So this one says the diameter and the height of a cone are divided by 3. Describe the effect on the volume. Well, we should know that if we're dividing by 3, that's the same as multiplying by 1/3. So we're going to take that 1/3 and we're going to cube it because we're talking about volume and the effect of it. We're talking about the effect on the volume. So that would be 1/3 to the third power. So 1 times 1 times 1 is 1, and 3 times 3 is 9, times another 3 is 27. So the effect would be 1/27. Now I want to show you what this would look like if we actually did the problem. So this would have been the volume of the original cone, and if we were trying to figure out what would happen to this as a result of each of the dimensions being divided by 3, we would then multiply that by our 1/27 or divide the whole thing by 27. That would give us 10.42 pi. So that's because everything was being divided by 3, so it becomes 1/27 of what it was originally. Our next one says the radius and height of the cone are doubled. Describe the effect on the volume. Go ahead and pause the video here and let's see if you guys can figure out what is the effect on the volume. So once again, we're looking for some key words here. It says that the radius and the height of the cone are doubled. Describe the effect on the volume. So that means we're going to pull the number 2 and we're going to cube it. So that means this shape is getting 8 times, the volume of this shape is getting 8 times larger. And just to show you how that would work out, the new volume, we would just multiply 8 times the old volume. So we would multiply 8 times 486 pi to get 3,888 pi centimeters cubed for our new volume. All right, so now let's talk about a pyramid. So the volume of a pyramid is related to the volume of a prism with the same base and height. The relationship can be verified by dividing the cube into 3 congruent square pyramids as shown. So basically, if I take this one and I create the blue one over here, the green one over here, and the yellow one back here, those 3 pyramids would create that one cube. So as we talk about pyramids here, the formula is similar to what it was before with a cube only, or with a prism, only we are now going to divide that number by 3 again, or multiply by 1/3. because it comes to, and the way I remember this is anything comes to a point we're going to divide by 3 or multiply by 1/3. So it says find the volume of the rectangular prism with the length, width, and height. So we're going to again multiply the 3 numbers together, the length, the width, and the height, and then we're going to divide that by 3. So in my calculator, I would have done it like this. Just multiplied those 3 numbers together and divided by 3. So our volume is 1,518 meters cubed. So this one says find the volume of the square pyramid with a base edge length of 9 centimeters and a height of 14 centimeters. We got to notice now that this is a square pyramid, so both dimensions of the base would be 9 and 9. So we're going to multiply again 9 times 9 times 14 and divide that by 3. So that would give us 378 centimeters cubed. All right, so go ahead and do this, check it out here, and then come back to me when you're done. So here again we have our bases, 6 times 4 times our height, which is 17. So we're going to go 6 times 4 times 17 and divide that whole thing by 3. That's going to give the volume of this pyramid, and this one is obviously a rectangular pyramid. So there we go again. That's 136 inches cubed. Okay, pause the video here and go ahead and do, well, actually, you know what? Not this one. You guys watch me do this one because this one has what was called the slant height, and we dealt with the slant height earlier. I didn't make a big deal about it, but I'm going to make a big deal about it now. So we don't have a picture for this one, so I'm going to go ahead and give you a pyramid. You can pause the video here. You guys can go ahead and draw one that looks like this. Okay, so this says a regular square pyramid with a base length of 12 feet and a slant height of 10 feet. So that means that both dimensions here are 12 and 12 because it says it's a square pyramid. Then it says I have a slant height of 10 feet. So that means it's this height out here. It's the slant. Well, I can't use that to solve this problem because I need the actual height, which would be in here. So it would be, that slant height was 10. What I just drew right there is the actual height. So I'm going to go ahead and complete this triangle here. Now what else I know is that this side right here, this triangle that I just drew, this dimension right here would be half of the 12. So I know that it's 6. So now I can solve for my height because this right here that I drew is a right triangle. So we're going to go a squared plus b squared equals c squared. So we're going to do 6 squared plus 8 squared equals 10 squared. We've seen this one multiple times, so that's 36 and 100. Going to subtract the 36 from the 100, take the square root of 8 squared and 64. So our height now is 8. That's what our height is right here. I'm going to go ahead and put 8 right here because we know that our height is 8. Now we can go ahead and solve for this by multiplying our base, 12 times 12, times our height and dividing that by 3. So we're going to go 12 times 8, divide that by 3. That gives us 384 feet cubed. So remember, when we're talking about slant height, we're talking about literally this measure out here because it is the slant of the object, and we're going to have to find the actual height, which always is going to be perpendicular to the base. So this one says find the changing volumes of the pyramid. So we're going to find the volume of pyramid with a base of 6 by 10 and a doubled height. So this time we are going to work through this problem with our formula, again, 1/3 base times height. But this time the height is doubling. So we're going to do 2 times 17, which is 34. And then we're going to work our problem. So you guys know how I do this in the calculator. 6 times 4 times 34 divided by 3. So that's 272 inches cubed. So we're going to talk about, again, what we talked about yesterday, or actually, yeah, yesterday. We talked about the intersection of a plane and a three-dimensional object. And when we do that, that's called what we call a cross-section. So we're going to look at some figures, some three-dimensional figures, and we're going to find out what the cross-sections are. So on this one, if we cut this cone horizontal to its base, then we are going to see that the shape that is the cross-section is a circle. If we do it vertical, perpendicular to the base, then we're going to get a triangle. Here, if we do it vertically, perpendicular to the base, again, we're going to get a triangle. Here, we're going to get, if we cut it horizontally, parallel with the base, we're going to get a rectangle. When we, again, cut it horizontally, parallel with the base, we're going to get a circle. When we go through its vertex up here, the apex of the cone and perpendicular to the base, we're going to get a triangle. And the last thing we're going to talk about today are solids of revolution. So on this one, if we take this right angle triangle and we rotate it 360 degrees, when we do that, we're going to get a cone. So if we were to rotate this all the way around a circle here, so in other words, we had an axis of rotation here and we started rotating this thing all the way around, we would get this cone.